thank you for the introduction and for inviting me to speak about this work. It's based on several papers that my co-author and I have written, and also some of the papers that I'm currently working with other co-authors. And the title of the talk will be Supply Chain Challenges and Blockchain Opportunities. And I'll start with the supply chain challenges. See if I can transfer from slide to slide without losing. Okay. So when we think about supply chains, these usually represent a combination of three types of flows. There are physical flows, the informational flows, and there are financial flows that enable creation of goods, services, and delivery of those goods and services to the ultimate consumers. I thought that it would be appropriate for me to use supply chain for personal protective equipment, PPE supply chain, as an illustration, given that this is the topic that has been in popular media recently, right, for obvious reasons. So if you think about how the PPE supply chain looks like, the final consumers might be located, say, in the US, and there are different kinds of consumers. There are doctors who work for the hospitals or medical offices. They are one kind of consumers. There are individuals who buy in PPE. They are served by different supply chains that are kind of overlapping with each other, but not necessarily so. Let's say the next level in the supply chain away from the consumers would be distributors, companies like McKesson. McKesson orders from manufacturers then order from their suppliers, contractors. It's a global system. About 70% of all of the PPE that comes to the US comes from China ultimately. And China is not the only supplier. There are contractors that are located all over the world, in Europe and Asia, everywhere. So the principal participants in this complex system are clearly consumers, whether they are hospitals or whether they're individual consumers, distributors, manufacturers, contractors. To enable the physical flow between them, there are also logistics companies that need to be involved, and all kinds of organizations that provide the logistical support. So think about shippers, think about ports. Clearly, the government is involved, import duties, customs, taxes, things like that, very important. That's on the physical movements of goods. But on top of the physical movements of goods, there are also informational flows. So to add to our list of participants in supply chain, we need to add companies that provide cloud services, communication services, databases, things like that. On top of those, there are financial flows. And so we need to add the participants on the financial side. This would be the companies that enable trade, like American Express, banks, commodity markets, insurance companies. And once again, I'll mention the government, the regulators. And the regulators and the government play a very important role here for PPE supply chain, specifically because there is a national strategic supply of PPE in the US. And for that national supply, there are procurement teams. Decisions need to be made, how much to buy, how much to pay, etc. And also at the state level, there are ordering decisions being made. So it's a fairly complex system. And normally it works quite well until we have disruption, until we have a catastrophic event like we had this year, when it becomes apparent where the difficulty of managing a complicated system like that lies. So what happened this year, right? So this is, this was a year of the pandemic, and we saw shortages of personal protective equipment. So hospitals couldn't get it, consumers couldn't get it. The shortages last for a long time. So why are there shortages? What happened is that clearly there is an increase in demand, right? You need the PPE for hospitals to deal with the pandemic patients. Also, there is a shock to supply. Vendors in China, where initially the pandemic struck, had to shut down their factories Logistics was disrupted as well. Because of the restrictions on international travel, logistics suffered significant disruption. So if you think about flights going from Europe or going from Asia to the US, either they are completely canceled or maybe there's one flight per week as opposed to a couple of flights every day. And so suddenly you have much less capacity to transport people. So you have this disruption, both supply and demand, and what connects them is affected. So what was the reaction? The reaction was try to get the needed PPE any way you can. And how can you do this? You have no idea where you can order PPE, who can deliver to you. So you start as a procurement team over ordering. You order from multiple distributors, you order more than you need. And if you get lucky and you get it delivered, then you cancel the orders that you don't need. So suddenly you have this explosion of phantom orders. From the perspective of manufacturers, the perspective of contractors, this is bad news because if you don't know how reliable demand information is, if you don't know how much you need to produce in the future, you are very reluctant to invest significant amount of money in order to increase your capacity, right? High uncertainty delays my investment decisions. And why don't we know how much capacity there is? Because we don't have visibility into the supply chain. We don't know where the capacity is available, where it's not available. We don't know where the inventory is in the process. Is it going to come from the West Coast, East Coast ports? We don't know if it's on a ship. Has it been shipped? Has anybody intercepted? So lack of information, big problem. Other manifestations of problems were that some hospitals, some states had PPE, but they didn't want to share that scarce resource with other states, other hospitals, because they weren't sure if they're going to be able to get the replenishment sometime in the future when they need it. So even so, there might have been some resources lying around, they weren't used effectively. Another manifestation of the problems was the competition that we saw between the procurement teams at every level. At the hospital level, procurement teams were fighting against other hospitals, against states, against federal procurement, all trying to get the same resources and lose it all. Ultimately, that added to the problems by having the procurement teams turn to the vendors who traditionally have not supplied the PPE. And the consequence of that was that there were many examples of either defective or counterfeit products flowing into supply chains and finding their way to the consumers. And of course, that is a problem. So it's quite dramatic, right? But maybe this is a one-time event, right? Who could have forecasted that this would happen? Who could have predicted this pandemic? Well, the problem is that the kind of disruptions, the kind of failures I just described, they're not unique to COVID. In every pandemic in the last 10 years, H1N1, Ebola epidemic, 2014, exactly the same failures of supply chain for personal protective equipment were observed and documented. There's a paper in 2017 by Patel and co-authors in the Journal of Health Security, which essentially lists these failures in the way that I described them. So this is not unique to COVID. In fact, people who work in supply chain, either on the research side or on the practice side, they long knew that there are some properties of supply chains, not just for personal protective equipment, but any kind of supply chains. Whether we talk about agricultural products, coffee, or we talk about airplane parts, doesn't matter. The structural problems embedded in the supply chain themselves, the way they operate, cause this type of disruptions, this type of failures. And so the argument I'm trying to make is that because of the knowledge that we have, this type of disruptions that we've seen this year to PPE supply chain are completely predictable. So if I'm going to get even more dramatic, I can narrow down the reasons for most of the supply chain failures to four harbingers of those failures, to four horsemen of supply chain failures. And those would be complexity of the system, the intrinsic randomness that the system is exposed to at every level, the fact that the multiple participants of the system have misaligned incentives, and lack of information, lack of visibility, right? You don't know either who is part of your supply chain. You might be surprised to hear that for most of the companies, they have no idea who their second-tier suppliers are. They don't have the visibility. You don't know what the capabilities of those suppliers are. You don't know what those suppliers are currently doing. So lack of visibility is a significant problem, right? And now, can we solve this? A new technology comes in 2009, Bitcoin, example of blockchain, and then after that, we have this technology being developed, and it seems like this technology might be able to help us to address some of these four harbingers of failures. Maybe informational failures, maybe misalignment of incentive, maybe complexity, maybe random. And so let's see if we can imagine how that happens. At least these are the claims that we hear in the popular media and in the industry kind of consulting publications that we have a blockchain revolution. Blockchain will solve the supply chain problems by providing accurate, incorruptible digital record of provenance, supply chain custody, record of processes, record of events, record of ownership, and this information will go to the right users, right? It seems like this is custom made to address at least some of the problems that we discussed about the supply chain. And in fact, there are many examples of companies trying to implement blockchain in supply chains to derive value along those lines. There are many applications in establishing the provenance and the chain of custody of goods, right? So think about you don't want counterfeit products to get into your supply chain. You want to know where those products are coming from. And we have examples of blockchain applications to establish and prove the provenance of things like fish, blueberries, coffee, pork, and all the way to the airplane parts. So Honeywell Go Direct Marketplace uses blockchain to record the ownership of the airplane parts to enable the trade of those parts. These are like repair replacement part for the airplanes, and you need to satisfy very strict guidelines what kind of parts you're using. So blockchain helps there to prove that these are the parts that are manufactured by the correct manufacturer, even if you're trying to resell it. So provenance and supply chain custody. The second big value that the companies are trying to derive from blockchain is use blockchain to prove ethical and sustainable sourcing, prove that fair trade practices are being followed. So examples here would be that you can use blockchain to prove how much you're paying to the farmers far upstream your supply chain and share that information with consumers. You can prove to consumers that the diamonds that you're selling are not coming from the countries that are in war. Or if you are selling electricity, you can use the information recorded in the blockchain to prove that this particular energy unit has been sustainably generated. Or if you want to create an offset, carbon offset, and you want to trade that offset, again, you can use blockchain to prove that this particular unit of energy has been sustainably generated and nobody else has claimed it as an offset for their carbon emissions. And the last source of value in the project that we've seen so far seems to be in improving the process efficiency in supply chain, providing proof of ownership, tracking assets as they flow through supply chains, and generating data with the goal of using the data for, let's say, trading and monetizing the extra data that you generate. And so examples here that probably many people heard about is TradeLens. This is the platform for shippers and ports and port operators and customers that keeps track of the ocean freight data. More than half of the ocean freight data now goes through this platform, according to them. Another example here is Tianjin Port uses blockchain for providing confirmation of rights, certificates of bills, for enabling trading, enabling financing, and kind of general supervision. And I guess that's important. They had a big problem in 2015. Explosion of unknown origin has destroyed huge part of the port, killed 173 people. And I already mentioned Solara example before. Their plan is to use the data from the sensors that they put in the panels and sell the data to traders so that those traders can have a more minute data information on this energy generated. So these are the values that we see from blockchain that the companies are trying to explore. Right? Now, question is this going to work? Many of these examples are still kind of in the pilot stage, even so they started maybe a few years ago when we started writing this paper, and I've been tracking some of them just out of curiosity, how they are doing. They still stay in pilot, many of them are failing. And that brings me to the next point I want to make, and that is we have to be really, really careful trusting the claims from companies about how valuable the blockchain is for them, because we've seen this type of claims before, whether it goes for ERP, RFID, 3D printing, AI, robots. The sales pitch from consultants tend to follow exactly the same pattern. They come to the company, they say the buzzword, blockchain. They claim it will change everything. Everybody's talking about it. The potential applications are endless. And now the clincher. We don't want to be left behind. And then if you push them, what exactly is the blockchain? They change to the next buzzword. Let's say AI, right? So we've seen this type of sales pitches before. And how do we know that blockchain is not just one of those sales pitches that the company is trying to sell? Right? In fact, there's some evidence that this might be the case. So on this graph, what you see are two curves. One is the Bitcoin price over the last 5 years. Another one is the number of Google searches worldwide for the keyword blockchain. And the remarkable part of these two curves is the fact that they highly, highly, highly correlated until about the middle of 2019, right? And so the argument one can give here is that the interest in the blockchain, if you think about the number of keywords searched blockchain as the interest measure, is probably driven by the speculation in the Bitcoin. That's why people were searching for it. Right? Now, the good news, 2019, they got decoupled, but the bad news is that the number of searches kept on going down. Now it's only 20% of the peak, which was at the end of 2017. Maybe people have learned about blockchain, they don't need to search anymore, or maybe nobody cares anymore, right? And in fact, here is the evidence that this all might be a hype. Every year, Gartner publishes its hype cycle where they map the emerging technologies against time and against visibility. And the idea here is that all of the technologies follow the same pattern. Initially, they go through the peak of inflated expectations when everybody has unreasonable expectations what those technologies will do. Inevitably, those don't get realized, and so we have a crash. And then we recover and go to the plateau of productivity. For the last couple of years, Gartner placed blockchain into the trough of disillusionment, so not very promising. What we try to do in our paper, series of papers, is try to understand, once we reach the plateau of productivity here, where the value of the technology will come from when it's applied to supply chain management. And that is kind of the contribution of those papers. This is not traditional academic papers. We don't have equations. We don't have tables. But we have a framework, and we have a discussion of what does it mean for researchers in operations management specifically, but I would broaden the scope. I think it applies to economics. I think it applies to finance, because the business models are applicable in multiple disciplines. And so here is our framework to think about the value. It's a nice balanced list of 5 strengths and 5 weaknesses. For every strength, there's a weakness. Right? Now, I'll start with the first strengths and then go with one pair at a time and illustrate with examples why this might be a strength or a weakness. The first strength is trust and information. This is the main strength of the blockchain. It's designed to be resistant to tampering. The information on the blockchain, the claim is, it's hard to modify ex post. So you can trust the records that are there. All of the applications of the blockchain and supply chain rely on this property of the blockchains. Whether we talk about provenance of goods, the proof where the goods come from. Whether we talk about allocation of scarce resources, we need to know who resources were delivered to, identities of the people who received them. Or whether we talk about trading resources, creating claims in the form of tokens that then can be passed on, traded, exchanged. Again, it relies on the fact that you can prove that this is the claim to this particular resource and nobody else has this claim. That's the trust and information that underlines all of this. This is the main differentiating factor of the blockchain against, let's say, normal, regular database. Because it's the biggest strength, it's also the biggest weakness. The weakness comes from the fact that somehow you need to ensure that the digital record corresponds to the physical reality. And this is really hard to do. People make mistakes. For instance, Republic of Chile minted a coin where they misspelled their country's name. Mistakes happen. If somebody is really, really motivated to enter incorrect information on the blockchain, they can bribe the person or people who are in charge of entering information. Let's say if you want to replace tuna with tilapia, and you still want to claim this is tuna, you can bribe the fishermen and ask them to claim that this particular record was for this tuna that they caught in these waters. But probably less obvious, but just as important, is the fact that real life is random. Physical processes are random. So even if you enter the information correctly on the blockchain, pretty soon, physical reality will diverge. And who is in charge of making sure that this is being updated? So because of this garbage in, garbage out type of problem, I was very pessimistic about the prospects of blockchain and supply chain management until maybe last year or so, when I saw companies figuring out partial solutions, how to address this garbage in, garbage out problem. So companies like often supply chain, they are using data from sensors, IoT devices, and doing analytics on the data, and using these analytic results to prove that, for example, fish was caught in the waters where fishing is allowed and not in the waters where it's not, based on the speed of the vessel, based on the geolocation, based on the video input. So you can trust that information more, that this is correct information. There are all kinds of tags that are being developed that are hard to counterfeit. At least you can prove that this is the asset for which you have the blockchain record. For instance, SIGPA has on a molecular level tags that they can use to tag oil and gas. And then that enables you to prove that this particular oil and gas going through the pipelines are coming from this particular source. So these are kind of examples that might help to tighten the connection between the physical world and the digital world. But still, it's a problem that is a big problem, the biggest problem. The next benefit of the blockchain is the increased visibility. Now, this is not the only technology that gives you increased visibility. Blockchain automatically gives it to you in the process of implementing the project. I mentioned that most of the companies have no idea who their second-tier suppliers are. This is really scary. And now imagine that you are implementing a blockchain, and in the process of overlaying the blockchain network on top of the supply chain network, you at least learn who the second and third-tier suppliers are. As you need to train people to use the app that records the information, you learn whether your suppliers use subcontractors and whether those subcontractors use subcontractors themselves. So suddenly you learn how your supply chain looks like, which is incredibly valuable. You also can use the information about the actual physical location of the goods at any moment of time to improve the velocity of goods going through supply chains, which is very useful. The downside of more information is lack of privacy. If you have to report consumer information on your blockchain, you're subject to all kinds of privacy regulations, GDPR in Europe, and the right to be forgotten. Part of that regulation is really hard to implement on the blockchain because the whole premise of the blockchain that you build in on the previous records as you build in your hash, right? And so this is difficult. But even if you don't have consumer data, there are all kinds of commercial concerns of sharing data. For instance, trade lanes by Maersk, for a long time, they couldn't get any other shippers besides Maersk to sign up because the other shippers naturally had concerns that by sharing data, they might be giving away competitive advantage to Maersk. Of course, there are ways of overcoming privacy concerns through encryption and all kinds of sophisticated solutions, but it still requires planning, still requires work, so it's not easy. The next strength is information aggregation. And this comes in two forms. First, you aggregate different kinds of information. You say when you record diamond provenance, you have IDs, you have videos, you have pictures, you have certificates, and you also aggregate it across multiple parties. So you aggregate it across multiple suppliers, multiple customers, and that is very useful when you're trying to analyze what's going on in your supply chain. What's the downside or what's the weak point? It's the lack of standardization. If every device that you have that generates data is on a different protocol, how are you going to put that on the blockchain? Or if you are a supplier to 5 large retailers and every one of those retailers have their own private blockchain, suddenly you have to train your people to operate 5 different blockchains if you are delivering to those 5 retailers. It's complicated, and the solution is obvious. You need standards. And in fact, there are numerous efforts in various industries, from transportation to energy, to establish standards that everybody needs to follow, to standardize. The next one is process automation. This is great when you have reliable, trusted information. You don't need to wait for human to make a decision. You can program through smart contracts certain decisions to be made automatically. So imagine in the context of PPE, right? You have a sales of PPE to a particular hospital. You don't need to individually have decisions made by the distributor, by the manufacturer, by the vendor. You can have the whole supply chain get the information that the sale happened, and the entire supply chain start working on replenishing these sold items, right? It expedites it quite a bit. This helps a lot, for example, in trade finance transactions, because in trade finance, you have this very complicated ballet of multiple paperwork floating around to establish who has the ownership at any moment of time, who paid, who hasn't paid, where the goods are, and you have multiple participants involved, ports, shippers, sellers, buyers, banks. And that takes weeks sometimes to get the transaction done. And so if you can put the trusted information in the blockchain and you can automate in the process that you don't need to like read and receive and make decisions, you can shrink the time quite a bit to get the transaction completed. And what's the downside? It's the black box effect. You need to trust that the process works in your interest. And if you don't understand as a user how this whole system operates, and most users don't understand, they don't trust the results. And also there are commercial concerns, whether or not you trust what the system, black box, is doing is in your interest. The last strength is kind of the least important, probably. It's the fact that you have a distributed system, distributed database, right? And even if part of the network goes down, the rest of the network can still operate. You can still record information. And then when reconnection happens, do the consensus reconciliation, hopefully. Of course, the downside of that is high inefficiency. And inefficiency, I think everybody has seen the comparison between the Bitcoin transactions 7 per second versus the Visa transactions 24,000 per second. But you can also measure inefficiency in energy consumption. So if Bitcoin were a country, it would rank approximately 40 out of all of the countries in the energy consumption, electricity consumption per year. Or another comparison is that one Bitcoin transaction is equivalent to more than 400,000 Visa transactions by kilowatt hour. And the reason you have an efficiency is because you have distributed network. You need to update the information on the distributed network, so you cannot avoid that. And also, some protocols for verifying the information are by design supposed to be slow to deter the attempts to tamper with the information, like the proof of work protocol. And of course, there are solutions to this problem, not perfect, but at least some solutions. Like you don't need to record the entire video. If this is what you're recording, you can record a hash of it, and that's sometimes is enough. You don't need to update the entire network right away, or you can use more efficient protocols. Instead of the proof of work, go for proof of stake or proof of authority, and that happens. So we have this framework, 5 strengths, 5 weaknesses, and we think it's useful for companies to think about when they're doing the blockchain project, what strengths they're trying to exploit and why it might not work for them, given the weaknesses that the blockchain has when applying to supply chain. But our audience in the papers is also academics. So for academics, we identify research themes based on the strengths and the weaknesses, and we see 3 major research themes. One is information that blockchain provides. Another one is tokenization, so ability to create claims, and those claims can be traded. And the third one is ability to automate the process. We take these research themes and we illustrate them on the examples of a range of problems, research problems and practical problems that operations management, supply chain management people have worked on for a long time, from bullwhip effect to supply chain risk management, to some novel applications like supply chain finance. My co-author and I are working on the supply chain finance applications using blockchain. And there are also new business models that blockchain enables that don't currently exist. And we talk about those, and we talk about pluses and minuses, potential research questions. And I hope that instead of going through those 12 or more examples, let me finish up coming back to the PPE. So I said we have these failures, and we know about the structural problems that supply chain have that lead to those failures. So blockchain could have helped. Of course, not ex post, but if ex ante we had it working in the supply chains. So how could have blockchain help? Where would it help us? Blockchain could have provided the actual demand data instead of the phantom demand, and that helps the manufacturers and contractors plan their capacity. It could have helped by providing information about where the production capacity is located, how much of it is free, and where the inventory is, and how quickly the inventory will be delivered. Blockchain could have helped by ability to create tokens for the scarce resources, whether that's inventory or the capacity. And if you have those claims, you can trade those claims in the markets, and the markets can more efficiently allocate those resources to the parties that need it the most. To deal with the defective counterfeit products, blockchain could have helped by providing the proof of provenance, chain of custody, conditions during the transportation, during the production. To make the supply chain quicker, it could have automated trade processes. And so the transactions could have happened much quicker. And finally, the visibility into processes allows you to react better to what your competitors and other people are doing, right? So this is potential opportunities. But for everyone, think about the weaknesses that we have, right? Do you want to share the actual demand data? Do you want to share how much capacity you have? Does that put you at a disadvantage in the negotiations with your customer or with your suppliers? Do you want to share how much you pay into the customers, to your suppliers, right? So it's not obvious that blockchain is the solution. It could have helped in some ways, how exactly it works, that's a research question. And Yao will talk about one example, how that works wonderfully. And I want to finish here, and if there's time, answer maybe a few questions.
Thank you very much, Vlad. So why don't we go into questions directly then? And so Agostino actually had a question in the Q&A, but I think it might work better if you just asked it verbally. So Agostino.
Thank you, Fahad. Yeah. Thanks for this great presentation. I would like just to ask, what are your thoughts about the difference between blockchain and the distributed database where I enforce the decentralized security protocol? So let's say there are a lot of databases that have been existing for a long time, where you basically can authenticate the users and give them permissions to execute specific transactions. And I always, I would be curious to hear your views on what blockchain adds to this already existing technology.
Absolutely. So the biggest strength of the blockchain and the biggest weakness is the trust and information. So the fact that you can prove, and sometimes legally prove, that a particular asset exists in the supply chain, this asset can be exchanged with somebody else for money, ability to prove that certain processes were followed. So as long as you don't have the trust question, the trust issue, then blockchain, in my opinion, is no better than the distributed database. I mean, there are differences, right? So if you have a whole range of blockchain technology implementations, right? So you range from something super simple, standard, that you can record some of the information on standard networks, like even Ethereum networks, as opposed to you designing a customized solution to your particular supply chain with limited access and all kinds of sophisticated features of zero knowledge proofs and things like that. So depending where you fall into this range, you might be better or worse than the distributed databases as far as the complexity of design and implementation. But to me, this is secondary. I think the primary differentiator is, do you need to trust and potentially legally verify the claims about the states?
Okay. Why don't we have a question from Laura Liu. Laura.
Yes. Hi, Farah. Can you hear me? Okay, great. This is Laura Liu. I'm from Guanghua School of Management at Peking University. So here in China, actually, many companies has been trying to use this blockchain system in their supply chain. But one problem they run into is, who is the ideal party to operate this blockchain? Because eventually, there should be somebody to maintain the technology and maintain this service, and more importantly, talking to different parties, try to convince them get onto the train. And the current situation is commonly there's the big company, and they operate the system, and they have some advantage. For example, like you mentioned, the first tier supplier get on the train, and then the first supplier can drag in the second tier and the third tier. So this big firm, this central firm, actually has a better management of their supply chain. But after all these firms are on their ecosystem already. And then the question is, if it's still around this big firm, why don't we just use your centralized system instead of blockchain? Right now, it seems like the blockchain is only used for copying the information. Yes, it has some usage, but seems to be still limited in terms of the advantage of the blockchain. And another approach I'm taking is a third party, like a pure fintech or technology company or an association. They are more neutral, or they're the third party. But the problem for them is they have less power to convince those people to join on the train. So eventually the question became, why I want to get on your train? So different firms around their ecosystem has their own train.
Yeah.
So yes, that's kind of, what's your view on this? This is the real question, and the practitioners are running into here.
Absolutely. So this is one of the most common questions I get asked when I talk about this research. And when I talk to the companies, and I participated in the blockchain forum last year in OECD in Paris. And the problems you identified are exactly the kind of problems that the companies are facing. So who should be running the blockchain? I don't think there's a clear answer. I think whoever derives, essentially it's a research question, because the benefits from having the system in place are not equally distributed among the supply chain participants. And it's long been a problem that supply chain researchers looked at. How do you redistribute the value among the participants of this value chain that creates incentives for everybody to contribute to it? And it's exactly the same problem here. You need to figure out a process to redistribute the value, whether this is some kind of contractual arrangements that somebody getting paid from the parties that benefit the most, or whether there's an argument one can make that, look, you're not getting payments, but look how much better your production process is if you're part of my blockchain, how much more reliable signals from me are. So it's a complicated research question. How do you prove that the value is distributed fairly, let's call it, among the participants of the blockchain? So it's an important but yet unanswered question. This is why I think this is an interesting area of research, because many of these questions, like at the high level, yeah, blockchain is wonderful. There's always wonderful benefits we can derive. And Vlad told us maybe it's not going to work all the time. But if you start digging like the questions you're asking, there are very important economic research questions that one needs to address.
So we have a, sorry, Laura, did that field your question?
Yes, thank you.
Thank you. So we have a question actually in the Q&A from my senior colleague, Haresh. So I'm going to actually unmute him so he can ask you verbally.
Thanks, Fahad. Good to see you, Vlad.
Hey.
I think my question is possibly related to the response you gave to the earlier question about as yet the limited scope in using blockchains. I mean, we talked about the this issue of who gets the benefit from using blockchains. This kind of goes back to a different technology, RFIDs, that Walmart had tried to propagate 10 plus years back. And they were in a position to push the cost down to their suppliers, even though Walmart presumably was deriving most of the benefits.
Yep.
So my question here would be, is there a different, easy to use technology which draws upon the strengths in the current framework that would enable wider adoption, presumably lower cost, and to me, most importantly, this issue of ensuring that this garbage in, garbage out effect is mitigated? So I'm going to mute myself. Thank you.
Yeah, this is a great example with the RFID. It's exactly the kind of question and the challenge that Laura asked and Walmart faced. And this is exactly what they did with their blockchain implementation. I think they just basically pushed it on the suppliers. And arguably one can say that, well, if you are supplying to Walmart, you're deriving some value from it and you wouldn't do it. And you would refuse to do it if you could walk away from this, but it's really hard to walk away from Walmart. So another thing I want to emphasize is that it's not just that there is this database value that suddenly you have the information available to you through the blockchain that you wouldn't otherwise have. Ability to prove that this information is trustworthy. You might be trusting this information within your supply chain, right? Like supplier, customer, second tier supplier, third tier supplier. You might be okay being on a centralized database within that supply chain. But if you want to share that information in a way that is trustworthy with parties outside, which would be financial institutions, regulators, consumers that are not part of the blockchain. This is the barrier of trust. This is the boundary where you don't have the trust. You might have the trust for the centralized database within your supply chain, but as soon as the information needs to get out, this is where you need some mechanism to derive that trust. And I kind of want to emphasize that, it's not a simple question of blockchain is better than centralized database or worse than centralized database. It really depends on the application. And you kind of need both in many cases. You need information being collected in multiple ways, stored in multiple ways. But when it comes to, do I need to communicate to the party that I don't know right now that I need to communicate to? Maybe I'll start exporting my goods into a different country and I need to prove to the government of that country that my goods satisfy certain conditions. Blockchain might help me if I have it in place to make that proof, right? And consumers, obviously, as well. If the consumers don't trust you as a company in itself. And as I mentioned, there's a range of implementation choices depending on the particular needs. The solutions could be as simple as recording certain transactions or the fact that you paid fair price, recording price information that you pay to the farmers on standard blockchain systems that currently exist. Or you can design highly customized solutions with very sophisticated bells and whistles that are addressing your specific needs. So there's no simple answer. The simple answer depends on your particular implementation. And I think for companies, what helps is finding a fairly narrow example of where they need to establish the trust, whether it's creating claims on assets, whether it's creating visibility, whether it's automating the processes, and then try to develop the project and grow from that. So I see many companies that they come, and when they discuss their projects in the blockchain, they say, well, we tried to implement the blockchain, but we failed. The reason we failed is because we didn't realize how much effort is involved on trying to organize everybody to be aligned to sign up on this blockchain. And then we didn't realize that they're using subcontractors. That's why blockchain is not working, because the subcontractors are not trained to use it. Yeah. So in many cases, blockchain is as good as just digitizing your supply chains. It's the same value. But on top of it, if you need to reach out to the third parties, then you need trust.
Thank you. I want to try to fit in just one more quick question here. Hannah, I have unmuted you. Please go ahead. Or Hannah?
Hi, okay. Sorry, my connection was unstable for a moment. So I was wondering, how does the use of blockchain relate to collusion? And there are two types of collusion that I can see. One is related to the trust issue. So all those supply chain blockchains are permission blockchains, and we trust the blockchain only as far as the blockchain validators do not collude. And because they're permission blockchains, they could collude and basically fake the blockchain. How far the trust goes here. And second is, once the supply chain becomes transparent with all the subcontractors and so on, now you can have all sorts of collusion between the players and cutting out middlemen, and maybe good and may not be good, or somehow colluding in pricing against some other players.
Both are really serious concerns. Both are really interesting questions. So the first one relates to, do you trust that the system works in the interest of the users if a subset of users can design it to kind of tilt the scales in their favor? And I don't have an answer how to prove it. I think it's kind of, as a non-economist, I would argue that we need to create some kind of mechanisms to verify that the system operates in the correct way, and the governance structure needs to be put in place such that you penalize this type of behavior. Now, how to actually implement it, I don't have the knowledge to speak to that. And again, black box effect is a big problem there. If verifying that, especially for the private blockchain, that the system operates in a way that the claims are made, it's intended to operate, I think it's hard. Maybe a little bit easier with the open code kind of solutions. And if the system is not super sophisticated, then it's easier not to obscure what the system is doing. And the second one is also a super important question. In fact, there is research, and I apologize, I forget the name. There's a professor of law at Harvard who explores exactly that question, which is, can blockchain be used to promote collusions, tacit collusions, right? Because you can create smart contracts that penalize participants of the cartel when those participants deviate from the cartel established rules, right? And you can do it in a way that's fairly obscure, but based on, let's say, pricing decisions that they have and things like that. And so I don't know of the actual instance whether anybody has actually tried to impose collusion in the industries using blockchain, but there is a research on this question.
Okay, thank you. In the interest of time, let's move on to the second presentation. Thank you very much, Vlad.
Thank you, Fahad, for the invitation and the introduction. So let me get started. So it's my great pleasure to be here today and share with you some of my research on blockchain and supply chain management. Just now, Vlad has given us a very nice framework for the strengths and weaknesses of blockchain and the potential areas of application of supply chain in blockchain in supply chain management. And next, I'm going to be talking about a particular application, which is to use the blockchain to improve the traceability in a supply chain. And this is joint work with Ming Hu from University of Toronto and Jingchen Liu from Nanjing University. So first, let me tell you a little bit about how we got interested in this research. Now, I think for people in this room, I don't need to introduce what is a blockchain. But in addition to being the technology behind the cryptocurrency, more recently, the blockchain technology has also started to be applied in supply chain management. And one important feature of this technology is that it is a decentralized digital ledger technology, so it can record transactions in a verifiable and permanent way. So once the data is recorded in the blockchain, it will be extremely difficult to alter the data. So that opens up all kinds of opportunities to use the blockchain to create value in supply chain management. So basically, in this study, we're going to be looking at the impact of blockchain-enabled traceability in supply chain operations. So in reality now, there are already lots of blockchain platforms that have been developed by startup companies, and most of them are trying to enable the traceability of the products in the supply chain. And this could actually create a big change to the supply chains, especially for industries where traditionally traceability would be very difficult to achieve. For example, if we look at pharmaceutical supply chains or agricultural supply chains, then the suppliers are usually the small individual farms, and there could be a lot of them. So traditionally, it is not really feasible to keep track of, which farm actually provided this particular carton of milk. So once a defect is found in the end market, then it's going to be very difficult for companies to know which supplier actually provided that defective product. So what happens in this industry typically is that once there is a defect, then usually the company will have to recall many other related products because they cannot really identify which are the products that are made by the good suppliers or the bad suppliers. For example, situations like this have happened with spinach related products and peanuts related products. So once something is wrong, then you have to recall everything. But now with blockchain, we can actually record all this supplier information in a verifiable and permanent way. So now if there is a defect, we will be able to know who is actually the supplier that is responsible for that defect. And then we can actually only recall the defective products. So that's going to change the supply chain operations, in particular the quality contracting in a fundamental way. And also in the modern world, supply chains are becoming more complex and globalized. So the production process could actually have many different stages, and each stage can be handled by a different company. Now, in this case, if we don't have the traceability information, then once something defective happens for the end product, it will be impossible for you to know which part of the entire process actually went wrong. But now with the traceability information, with the blockchain technology, we can basically record everything that has happened to each product. So we will also be able to identify which part of the process actually went wrong, and then we can impose the penalty terms accordingly. And right now, like I mentioned previously, there are a lot of blockchain platforms that have been developed. Most of these platforms are developed by startup companies to improve the traceability of supply chains. And IBM is also doing a lot of work in that area. For example, there's the IBM Food Trust Group, which a lot of the leading retailers around the world have started to use. And also, leading retailers around the world have started to utilize some of these blockchain-based platforms to improve the traceability of their products. For example, Walmart and also Alibaba and JD.com in China. So what they are trying to do is, now for the consumers, by simply scanning a QR code, they will get access to all the historical information for this product. And these companies are also trying to use the traceability information to address some of the food safety issues. And now I have a particular example to show you. This is an example of a blockchain platform that is developed by Oting to trace the pork supply chains in China. So basically what happens there is, by retrieving the blockchain information, you get everything that happened to this, say, this particular box of pork that you are purchasing, all the way from the feeding process, the farming, production process, and the logistics process. Okay, so first of all, we have the information about the original supplier for this particular item that you are purchasing. For example, in this case, this pork is originally provided by this Donglian farm. And also the blockchain can be used to record other types of information that are related to the quality of the products. For example, the temperature, the humidity of the feeding environment, light conditions, and the vaccinations of on the animals. So once a defect is identified by using this quality information, companies may be able to identify which part of the process actually went wrong, and then they can actually impose the penalty terms accordingly. So our research is motivated by this recent industry practice, and we want to understand how does the blockchain-enabled traceability affect quality contracting in the supply chain. We're going to consider a supply chain that has one buyer and multiple suppliers. And furthermore, to understand how does the impact of traceability depend on the structure of the supply chain, we are going to analyze two types of supply chain structures. First, we are going to consider a serial supply chain. So in this case, we have one buyer and a downstream supplier and an upstream supplier. So here you can see the two suppliers are actually located in different tiers of the supply chain, and they each take care of a particular production stage. And second of all, we are also going to analyze a parallel supply chain. And in this case, the two suppliers are located in the same tier of the supply chain. So they're basically making the same thing and provide the same thing to the buyer. Now, in the serial supply chain, because the two suppliers are actually taking care of different production stages, the production they make is actually different. Now, in this case, if we have the traceability information, we will be able to trace the entire process of the production. So we can actually identify which production stage is actually the defective one. And if we look at parallel supply chains, in this case, all the suppliers are making the same products to the buyer, and then the buyer is selling all the products to the customer. In this case, if we have the traceability, we will be able to know which product is made by which supplier exactly. So now if some suppliers turned out to be defective, then we only need to recall the products that are made by those defective suppliers. So we term that kind of traceability the product traceability. So in this paper, basically for each of the supply chain structures, we are going to compare the case without traceability to the case with traceability, and then we will be able to uncover the value of traceability in different types of supply chains. Okay, are there questions at this point? Okay, now let me continue. Okay, so before I jump into the details of the models and the results, let me just very briefly mention the streams of literature that are related to this paper. In terms of the modeling, our paper is related to two streams of literature in OM. First, in OM, there is the literature on supply chain quality management. Now, in this case, most of the models capture a supply chain that has a single buyer and a single supplier. And there are also models that looked at supply chains with multiple suppliers, and that's also the situation for our case. So our paper is more related to this stream of literature. And for supply chains with multiple suppliers, the OM literature has also studied other operational issues, such as the procurement issues and issues related to responsible sourcing. And of course, our paper is also related to the blockchain literature because our primary motivating example for this study is going to be the blockchain technology. All right, now let me get started with our first supply chain structure, which is the serial supply chain. Let me first introduce our model setting, and then I'm going to show you the main findings. Basically, in this case, we have a three-tier supply chain. So the upstream supplier will first make the production, and then the downstream supplier will make the production, and the buyer sells the final products to the market. So both of the suppliers will be making a decision on the quality. So in this model, we define quality as the probability that the production of this particular supplier is going to be non-defective. And then to improve the quality level, the supplier will incur this convexly increasing quality cost. And finally, the end product quality is jointly determined by the quality from both suppliers, following the weakest link poverty. So what that means is for the end product to be non-defective, we need both suppliers to be non-defective. Okay, so that's the weakest link poverty. And then the buyer is going to sell the products to the market, and there could be two possibilities. The first one is if the product turns out to be good, then the buyer will receive the retail price P. And if the product turns out to be defective, then the buyer will incur a market loss L. And you can consider this market loss as the extra cost that the buyer will have to pay in order to handle the product returns or the product recalls. Okay, and then to incentivize the suppliers to improve the quality levels, the buyer offers a contract to the downstream supplier. So here what we have is a contingent payment contract. Okay, so in this case, consistent with the moral hazard settings, we assume that the quality decisions of the suppliers are unobservable, so it cannot be contracted upon, but we can contract upon the realized quality outcomes. So depending on the actual quality realization, the buyer is going to either pay a wholesale price to the downstream supplier, or he doesn't pay the wholesale, the downstream supplier. And then similarly, the downstream supplier offers another contract to the upstream supplier, and it is also going to be a contingent payment contract. So either the upstream supplier gets paid with wholesale price or not. And then the exact condition for this wholesale price to be paid will depend on whether there is traceability in the supply chain or not. So now let me give you some more details for the two cases without traceability and with traceability, and let me clarify on the payment mechanisms.
Yeah, can I ask you a question?
Yes, please go ahead.
The price, is that an exogenous parameter of the model, or is it going to be somehow endogenously determined?
Right. So in this work, the price and the market laws, those are both exogenously given. The decision variables are the qualities from the suppliers and the wholesale prices.
Okay. Okay. Thank you.
Mm-hmm. Okay. So next, let me show you the model for the case without traceability. Now, in this case, we don't have traceability. So if the end product turns out to be defective, there's no way that we can know which supplier actually caused that defect. So the payment can only be made contingent on the actual quality level of the end product. So what happens is actually quite simple there. If the final product is good, then everybody gets paid. And if the final product is bad, then nobody gets paid. And under this setting, we can write down the problem formulation following the sequence of events. Basically, first, the buyer will decide on the wholesale price to offer to the downstream supplier. And then the downstream supplier will decide on the wholesale price to offer to the upstream supplier. And finally, the two suppliers will decide on the quality levels. Okay. And under this setting, what will actually happen? Okay. Now, in the serial supply chain, here you can see that the contracting process is actually a sequential contracting process. And the downstream supplier here is actually playing a dual role. In his relationship with the buyer, the downstream supplier is the agent, but in the relationship with the upstream supplier, our downstream supplier actually plays the role of the principal. Okay, so it's a dual role played by the downstream supplier. And because of that unique feature in the serial supply chain, we will have a double moral hazard issue. So the traditional moral hazard issue will be distorted even further. Okay, so let me explain what will actually happen in that case. So in this case, the downstream supplier receives the payment from the buyer, and then he needs to think about how to spend the money. So here he needs to do two things. First thing is to pay the upstream supplier to induce the upstream supplier to also improve his quality. And the second thing is to spend the money on improving the quality of himself. That's the two things that the downstream supplier will need to do. Okay, so essentially the trade-off is given by how much money is spent on the first thing and the second thing. If the downstream supplier spends money on improving the quality himself, then he pays only the quality cost. But if he pays the upstream supplier to induce the upstream supplier to improve the quality, then he will incur both the quality cost and also there's going to be an agency cost arising from the moral hazard within this relationship. Okay, so that means it is going to be less efficient for the downstream supplier to actually pay the upstream supplier to induce the quality level from the upstream supplier. So what happens in equilibrium is that the downstream supplier is going to keep most of the money to himself to improve the quality himself. So the upstream supplier is not sufficiently incentivized, and then he's going to choose a much lower quality level. But because the final product quality is determined by jointly by the two suppliers, if the upstream supplier is not properly incentivized, then the overall quality in the supply chain is not going to be good. Okay, so that's the the consequence of the double moral hazard issue in the serial supply chain. Now, if we also don't have the traceability, that means the payment can only be made contingent on the quality of the final product. Okay, so that means the upstream supplier can also be penalized because of the mistake from the downstream supplier. Because even if the upstream supplier is good, if the downstream supplier is defective, the final product is still defective, so the upstream supplier will still not be paid. So that feature will further, make the double moral hazard issue even worse. Okay, so that's the main issue without the traceability. And here you can see that if we have the traceability, then the payment rule can actually be made better, and then we can incentivize the upstream supplier in a better way. And now let me show you what happens in our case with traceability. So in this case, instead of making the payment based on the final product quality, we also know what is the quality outcome up to each stage of the supply chain. So we can actually make the payments based on that. Okay, so what happens here is the upstream supplier will get paid as long as he is good himself. Okay, so that's the main difference from the previous case. And if we look at the downstream supplier, okay, so when the buyer pays the downstream supplier, that payment will depend on the actual quality of the product that the downstream supplier delivers to the buyer. So that means his payment will be dependent on the quality level up to this stage of the supply chain. So if the downstream supplier is defective himself, of course, the final product will be defective, so he doesn't get paid. And if the downstream supplier is good, but the upstream supplier is bad, then the overall product is still bad. So the downstream supplier still doesn't get paid. Okay. So here the key point is the payment rule is based on the actual quality of the product that is being delivered at a particular stage. And I'm guessing some of you might be wondering, okay, so why didn't we consider an alternative payment rule, which is the payment is only based on the quality level of the particular supplier for that particular stage, okay? And we actually looked at that case, and we found that it will actually not going to, it is actually not going to work. And let me tell you why, okay? So now let's suppose that the payment is only based on the particular supplier that handles that stage, okay? And let's see what will happen. So here, let's consider this sample path. Let's suppose that the upstream supplier is defective, but the downstream supplier is good, okay? So if the payment is only based on a particular stage, then in this case, because the downstream supplier is good, the buyer should pay him. But because the upstream supplier is bad, the downstream supplier will not pay the upstream supplier. Now, in this case, the downstream supplier will actually have an incentive to induce a lower quality to the upstream supplier, because it is more efficient to keep the money to improve his own quality anyway. And in this case, eventually the downstream supplier will reserve all the money to make sure his own quality is very good, so he gets paid, all the time, but he doesn't have to pay the upstream supplier. So that's going to kind of push the double moral hazard issue to an extreme. Okay, so what happens in equilibrium is that the downstream supplier will pay zero wholesale price to the upstream supplier. So the upstream supplier will not work on his quality, and then the buyer can anticipate that. So the buyer knows my product is going to be extremely bad, so I'm not going to pay anyone anything. So eventually there will be a failure in the supply chain. And that's the important reason why we actually need to use a payment rule that is based on the quality up to a particular stage of the supply chain, okay? All right, so next, let me actually jump to the final results part. Okay, so basically what we did in the paper is we first characterized the equilibrium for the case without traceability, and then we also did the case with traceability, and then we compare the equilibrium. Okay, so by comparing the equilibrium, we will see how will traceability impact the quality contracting in the supply chain. Okay, so one thing we have seen just now is that if there is a traceability, then the upstream supplier will not be over penalized by the mistake of the downstream supplier. So it will be easier to induce the upstream supplier to improve higher quality. So that's going to happen in equilibrium. And also because it is easier to incentivize the upstream supplier, the downstream supplier can actually pay less to the upstream supplier, and then he can keep more money to improve the quality himself. So the downstream supplier is also going to obtain a higher quality. Essentially, the quality will be improved all along the supply chain. And if we look at the total profits of the supply chain, we also find that the entire supply chain can benefit from this effect of mitigating the double moral hazard issue. And then all companies will actually be able to receive a higher profit. So that means the incentives to initiate blockchain and traceability can be naturally aligned across all the companies. So anyone could actually take the lead to initiate the blockchain, and then the other companies will want to join. Okay. And we further analyzed the differential impact on the two suppliers. And what we found is that the upstream supplier is going to receive bigger improvement compared to the downstream supplier. Okay, so what that means is once blockchain is used to improve the traceability in the serial supply chain, it can also help protect the upstream of the supply chain to a greater extent. And from an operational point of view, we would think that's a good thing for the supply chain, because in the OM literature, we know that typically firms operating on the upstream of the supply chain also face more operational challenges. For example, there is the Booth effect, which will cause the variability in the inventory ordering to become bigger and bigger if we go from the downstream to the upstream. And also, if we look at the agricultural industry, which is a primary area of application for blockchain-enabled traceability, usually the upstream suppliers are small individual farms, so they are small companies, and they could be very vulnerable to other challenges such as the supply chain disruptions. So now, if by having the traceability, we can give them more advantage, then that could also help the entire supply chain to be more likely to sustain in the longer term. Okay, so I think I still have a few minutes left. Let me briefly show you our main insights from the parallel supply chain.
Let me just, feel free to extend a little bit on the time. I think we can overrun a little bit if don't rush too much.
Okay, thank you. All right, so for the parallel supply chain case, here the two suppliers, they basically make the same stuff. And then the buyer is selling both products to the market. In this case, what our model tries to capture is if we don't have the traceability, then we will not be able to keep track of which product is made by which supplier. Okay, so even though we know one supplier is just defective and the other one is good, we still cannot know which products to recall. So we'll have to recall all the products from the market as long as there is one defective supplier. But if we have the traceability, then we can actually recall the products in a flexible and accurate way. So in that case, we know which supplier is defective and we know which products were actually made by that supplier. So we only recall those products. And then for the other supplier, we don't have to recall the products and we can still pay that supplier the wholesale price. So that's the main feature of our model here for the parallel supply chain. And then in terms of the findings, here let me introduce let me focus on the part that is different from the serial supply chain. First of all, we find that different from the serial case, in the parallel supply chain, traceability does not always improve the product quality. In this case, traceability will actually lead to two effects. The first one, we call it the economic effect. This is actually similar to what happens to the upstream supplier in the cereal supply chain, because in this case, when we have the traceability, the suppliers will not be penalized for the other suppliers' mistake. So it's going to be easier to incentivize the suppliers to improve quality. So this economic effect will improve the quality in equilibrium. But there is also a competing effect. We call it the operational effect. Okay, so in this case, the buyer can actually achieve flexible product recall. So he can only recall the products that are actually defective. So that's going to save on the cost for the buyer. And then the buyer is less afraid of having a defect. So equilibrium, in equilibrium, what happens is that the buyer will pay a lower wholesale price to the suppliers to induce a lower quality. So that's going to cause a different effect compared to the economic effect. And essentially, how does the equilibrium quality change will depend on the trade-off between these two effects. And what we found is that if the market loss due to defect is higher than the threshold, then the equilibrium quality will actually decrease with traceability. And that is because when the market loss is huge, then the savings from having the flexible product recall will be more significant for the buyer. So the operational effect will be stronger, and it will dominate the economic effect. Okay. And also because of that reason, we have found that the supplier's profit is not always improved with traceability. Okay, so because if the market loss is very large, then the buyer will pay a lower wholesale price to the suppliers when there is traceability. So the suppliers will actually be hurt in equilibrium. But the total supply chain profit will actually be higher. And that's because, right, so for the economic effect, it essentially mitigates the moral hazard issue between the buyer and the supplier. So that's better for the supply chain. And then the operational effect is basically, you know, we have the product, the flexible product recall. So that can also save on some additional cost to the supply chain. So both effects are actually good for the entire supply chain. It's going to be an improvement for the supply chain, but the improvement is not going to be Pareto improvement because the supplier can actually be hurt. So the takeaway is if we have a parallel supply chain, then the buyer will most likely have to take the lead in initiating the blockchain and the traceability. And then in certain cases, the buyer will also have to compensate on the supplier so that the supplier can also improve the overall profit with traceability. Okay. And finally, to summarize the key findings of this paper, we have looked at two different kinds of supply chains, and then we have found that the value or the impact of traceability can be very different depending on the supply chain structure. If we have a serial supply chain, then the traceability is always able to improve the quality of the supply chain. But if we have a parallel supply chain, then traceability can actually lead to a decreased quality level. So what that means is the blockchain-enabled traceability, we believe, is easier to be implemented in long chains with many tiers in the supply chain, but it will be less likely to create value in to be implemented in the flat chain with fewer tiers, but within the same tier, we actually have many different suppliers. And that is the end of my presentation today. Thank you very much. I'm happy to answer questions or discuss further offline.
Thank you very much, Yao. So if to the audience, if there are any questions, please raise your hand using the raise hand function. It does not look like we have any questions. So let me or wait, there's something in the Q&A. Okay, so there is, I'm gonna actually unmute the person asking in the Q&A so that question can be asked verbally.
Actually, pretty quick question, guys. This sounds very interesting, traceability, but the traceability here, as a reflect, you're trying to use the traceability to represent the blockchain, right? So the quick question is that how's that different from RFID as we studied in the past, right? Second question is that, well, you hadn't talked about any cost implementation. I guess one of the issues RFID had in the past is that all the benefit it promised may not necessarily, incentivize all these party involved, right? And also, of course, the conclusion could be different if anything like the cost associated with different party involved here. Would you have any insight about that ahead of time?
Yes, those are very good questions. So I think essentially what we did is we basically left the insights more like in an open-ended way. So what we did here is a theoretical study, and then by looking at the equilibrium profits of different companies, we can generate insights regarding which firm is more likely to be the company that can benefit from having this traceability in the supply chain. And then but some other companies can actually be hurt because of the traceability. So in reality, that means the other company will not have the natural incentive to join the blockchain platform. So from this theoretical prediction, what we can tell is that the leading company will actually have to compensate the other companies in the reality. And then I believe there are possible ways to implement that in reality, for example, by changing the wholesale prices a little bit more, or by using other kinds of contracts. But of course, it will also depend on how the companies collaborate and negotiate with each other in reality. And then you also asked a very good question about RFID, right? So I agree with you. Other more traditional technologies can also be helpful to a certain extent to achieve some of the benefits of blockchain, such as enabling the traceability in the supply chain. Okay, so so what we are doing in this paper is we are looking at what is happening right now in industry practice, and then the traceability is actually a primary application of the blockchain technology. Okay, so of course we believe there are some new features in that technology, and so they can actually record the information in a more verifiable and permanent way. So that does give the technology more advantages compared to the traditional technologies. But I also agree with you that some of the benefits that we can see from this study may also to be achieved with other kinds of technologies. Right? So in the paper, we actually motivate the study in a more general manner. And so blockchain is the primary motivating example, but we are not saying blockchain is the only technology that can enable traceability. It can also depend on the exact situation. Right. Thank you for the questions.